can RISC-V be part of vision of democratizations of artificial intelligence?
Yes, it is. RISC-V is one element. In general, in Axelera, we try to keep open as much as we can our software stack. We are using open source code. We are using TVM in the backend of the compiler. We are using Zephyr in the firmware, which is an open source supported by Intel. We tried to use also one API. I mean, we are trying to use as much as possible open source and also to give back the community. In AxeleraAI, most of the hardware, many hardware guys are very active in the RISC-V communities. And then we want to give back to the community. We want to develop things, create our own architecture and our own product, but still based on open source. But I think that when I say that we want to democratize AI, it also means that we want to have a product which is powerful, usable, and low cost. For example, if you take our solution that we design, which is a chip of more than 200 TOPS, we are positioning this already in a card at $149 because we want people to use it. We want to give the access to a powerful solution to people. There is always time to make money. But the first thing is to have people to create great things using our technology. And if they succeed, we succeed. Then we think that it's important to have something that's easy to be used, high performance, low cost, that you can buy online, that you can get it everywhere in the world, and you can just do great product around. We want to unleash innovation.
As for AI accelerators, what are the advantages of using RISC-V?
Well, it's the advantage is that we can control it because it's open source. We can design, we can control it. We don't have to go back to anyone and ask permission or ask a source code of the compiler. You know, if you use whatever IP from Cadence, Synopsys, ARM, it doesn't matter. You cannot access to everything. You start to rely on them and this can be a problem in the long run. Therefore, with RISC-V, you can just control completely your architecture. And it's a platform which is tested by a large community, which is good. And you can extend and develop it. For example, we are developing a vector instruction, a specific vector instruction set units, which will be integrated in next generation. And we can do it by ourselves because we have the knowledge and it's an open source platform. Then we don't have to, negotiate with supplier to solve the problem.
Do you think AI applications will become an important driving force for the RISC-V ecosystems?
It's easier to use RISC-V in an application-specific chip than in a general purpose. Because in application-specific chip, you can use RISC-V and optimize the RISC-V for what you want to do. And then you have to verify it only for what you want to do. But if you want to use a RISC-V as a general purpose processor, and you want to use it to compete with a cutting-edge Intel CPU or cutting-edge AMD CPU, then it's a different story. It's way more difficult, and it requires way more resources, way more time, because it's a new architecture and it is not so highly verified by everybody. In the sense, when you go to complex things, you need an ecosystem around. You need the drivers, you need support from the community, from Microsoft, from Ubuntu, from Linux in general. Then it becomes more difficult. Then I think that RISC-V will grow now thanks to AI, and it will take still 5 to 10 years to become a real general purpose solution alternative to what you have today. It will take time to have a RISC-V running a mobile phone.